Hi, today we're looking at section 1.7, which is analyzing puzzles and games. Now, our notes for this are fairly short because each puzzle and game is its own unique pattern. So therefore, we'll just look at a couple and then you can get into practice work to help try to find patterns in other games. So we're essentially utilizing the same inductive and deductive reasoning as for previous sections. However, now we're just applying it to puzzles and games. So for example, a student needs 66 points to win a dart game. Now, if they need exactly 66, they can't have more or less. So we want to come up with 3 separate ways to win, and they get 3 throws. Now, in darts, the numbers as you go around the board correspond to each of these triangles, how many points you get in them. Now, if you get in, say, this section, so the second most outer ring and the fourth most outer ring, that is just the exact value you have here you get. However, the points you get can be multiplied also depending on where you are. So if you're on this outer ring, you get 2 times whatever number's out here. So if I got here, 2 times 20 would give me 40 points. Or here, 2 times 4 would give me 8 points. If it's this inner small ring, it's 3 times the amount of points. So if I got here, that would be 3 times 20, which would be 60 points. Now, the center bullseyes were 50 and outer bullseye is 25. So we want to come up with 3 ways to get exactly 66 points. So for example, I could get right here, let's say, so a double 20, which would put me at 40 points. I'd still need 26. So I could then, for example, get a single 18. So I'd have 40 plus 18 be 58. I still need 8 more, so I could potentially get a single 8. Okay, so let's try look at another one. So for example, I could get a triple 2, which would give me 6. So I would still need to get 60 more points. I could then get, say, a triple 18. So I'd have 6 and 54. So I just need 6 more. So I could, for example, get a double 3. A third one, let's throw in a bullseye. So we have a bullseye. That gives us 50. We need 16 more. So I could, for example, get 13, single 13, and a single 3. Okay, so next we have this grid with numbers in it. We want to see if we can notice any patterns in this. Okay, so looking at this, if I go horizontally, I can see all these numbers go up by 4 when moving horizontally. If I move vertically, so 5 to 8 to 11, 9, 12 to 15. So moving vertically, our numbers increase by 3 each time. Now, we can also look at potentially adding these. So 5 plus 9 is 14. Plus 13 gives us 27. 8 plus 12 is 20. Plus 16 is 36. 11 plus 15 is 26. Plus 19 is 45. 5 plus 8 is 13. Plus 11 gives us 24. Then we've got 9 plus 12 is 21. Plus 15 is 36. And then we have 13 plus 16 is 29. So 13 plus 16 plus 19 gives us 48. What I notice with all of these is if I add up along a row or column, I get exactly 3 times whatever number's in the middle. So 27 is the same as 3 times 9. 36 is the same as 3 times 12. 45 is the same as 3 times 15. 8 is 8 times 3 is 24. 12 times 3 is 36. 16 times 3 is 48. So we can also say adding numbers horizontally. We get 3 times middle term. And adding things vertically, we get 3 times middle term. Okay, so like I mentioned, this section, we're purely looking for patterns in games and puzzles. So things like what was brought up here, as well as the previous example.